Hello, I'm Carl with Sherline Products. This video we're going to go over tooling, setting your tool offsets, and going through a program. So what we have is our brand new Sherline ball screw lathe, our final design that we're really pleased with. What I have for tooling, for starts, I have on the back side right here is a part number 2262, which is our 55 degree insert holder that's straight, it's not kicked off at any angle. It's in our 7604 rear mount tool post, which is for our 3/8 tooling. In the middle I've got a boring bar, which is our number 2273. And I'm actually using this boring bar as a turning tool. It's a 55 degree. It's also mounted upside down so that as it's cutting, all the chips are falling instead of coming up all over the place. As far as using it this way to cut, it works really well. It is kind of a pain to get the insert out if you have to change it, but if you're not cutting hard materials, then just having all the chips falling down instead of coming up in the air is well worth it. And then on this one, I've got a top notch or top clamp threading grooving holder, which is our number 2267. So for the program that we're going to be doing, it's going to do turning and threading. The way I have it set up also is the stock we're going to be cutting is 3/8 diameter brass. And if you notice my spacing between the tools, I've got 1.5 to 2 inches spaced between tools. You have to bear this in mind. If you're turning something that's 3/8 or 1 inch, you have to have the correct spacing between your tools. Otherwise, when one tool's cutting on the back side, the other one could actually be crashing on the front side or vice versa. So the spacing's good. I have all of them are out about the same Z level. So I won't have a situation where when this one's cutting, this one's actually crashing into my chuck or harpooning my headstock, okay? So what I'd like to also point out is that I don't want my boring bar sticking out much further than it needs to be. So this is actually more than it needs to be, but it's legit where it's at right now. However, it's also sticking out of the back side. So the next thing to bear in mind is this is my tailstock situation back here, and this is all the way back as far as it can go. Now, if I home out my machine, I'm going to hit Control Alt and home. Okay. Let me jog it first so I have some time. I go Control Alt Home. It's always going to home in the Z first, and it's going to home in the X. With the boring bar sticking out this far, when it goes to home in the X, it's actually going to crash into my tailstock. All right, so what you want to do is have your tailstock actually pulled back out of the way, and then we'll lock it in when we see it home out. So that's my home out, and you can see that would have been a pretty nasty crash right there. So just a little tip before you get going and wipe out your tailstock or crash your tool. So right now we're homed out. I've got my 3 tools. Okay, so I'm going to go to, well, first we'll put our stock in. The final Z-axis depth of cut in my program is about 970, so I need to have the stock sticking out further than that or I crash my chuck. So I'm going to have it sticking out about 1.150 from the face of my chuck, or from the chuck jaws rather. Okay. We're still good. Then I'm going to tighten it up good and tight. Okay, now as far as the stock sticking out, a lot of how your parts turn out and the tolerances you can hold depends on how you have it set up to run. The general rule of thumb for stock, for any stock, is that the distance it should stick out past the face of the jaws or the front of your collet is 1.5 times the diameter. Okay, so this is 3/8 stock at 1.15, we're exceeding that length right now. We can get away with it with brass, and the amount of flex you're going to get is not going to be enough to have the part come out of tolerance. However, if it was harder material, or if I was sticking out further, if I'm sticking out further, then you've got to have some kind of support on the end, a live center in your tailstock to actually support it, or you're going to have chatter, vibration, and your diameters are going to be all over the place. So the other one too is you, depending on how far it's sticking out, you're going to have to adjust your RPM range probably down in order to get rid of chatter. If it was in closer to the chuck, I could spin a lot faster than I can with it sticking further out. So anyhow, this is our setup for that. So now we're going to go to the F4 tool workstation number. And I'm just going to show you this right now. Right now we're at the home position. We're all the way homed out. So on the first one here, actually let's go back to MDI. First thing I'm going to do is call up tool 0. Whenever you're working with a tool, you have to call that tool up first so the computer knows that's the tool that's in the holder that's being used. So the code is T0 M6. I punch that in and my screen shows T0. So it knows I have tool number 0 in there. Now if I go to the F4 tool page, I go to 0 and I double click on it. For tool 0, I always leave this blank. So I either punch in blank or I punch in G53 because this is going to represent a tool that's homed out at my machine 0. And G53 is my machine 0 point in X and Z. So I'm going to punch in G53 and I'll punch in blank. So right now where the machine is all homed out, I'm going to click on Z0 and then I'm going to go touch at 0 diameter and I'm going to go save. Right now the machine, that's my tool 0, it's zeroed out at the home position. Now if I go to my jog page with tool 0 in there, it's all zeroed out at the X and Z. I jog, I'm on continuous. Wherever I go, it's giving me a direct readout of the distance I just traveled from X, Z, 0 on the machine to wherever my cross light is on the machine. And this comes, it's handy for different things as you go along. If right now, the other one too is if I want to go back to my home position, I can either go to my MDI page and go home all access, or because that is legitimately G53, if I go G53, G90, G0, X0, Z0, it goes back to my home position. Another little tip. Right now, I'm going to touch off my tools and we're going to start with my tool number 1. So again, on the MDI, I'm going to hit T1, M6, and you'll see the screen changes to T1. Now I'm just going to go to jog, and what I'm going to do is, because this one's at an angle, I'm going to eyeball the very tip of the insert right at the front side of my part for Z. For the X, we're going to touch off. Again, I'm on continuous, it's flashing red. I'm going to bring my holder down. Another rule will actually touch off. If I measure the width of my insert, I'm at 280. So what I can do is actually come in and touch the side to the face of the part and then shift half of that. So what we will do is jog in until we have the edge of the insert in front of the part. I'm going to go to step mode. Step in 10th out at a time here. And now I'm going to go into Z. That's close enough, we're right there. Now I'm going to go to my Actually, we'll jog out of the way. X plus, the clearance point. There we go. Okay, now it was 280, so I'm going to go MDI, go G91, GOO, Z minus 0.140, which is half of that. G91 is incremental, so it's going to move that amount from where we are. Enter. So it just moved 140, so that's where I want my Z0 to be. Now I'm going to go to tool 4, and I'm going to double click on tool number 1. So right now there's nothing up here. I'm going to call this 55 backside. That's my name for it. For the Z axis right now, I'm just going to click 0. So right where it is, that's where I want Z0 to be. And I'm going to click save. All right, let's go back one more time. You can also see right here, it's got backside or front side tool. Right now the box is checked for backside. If I uncheck it, the arrow goes to front side. So right now, number 1 and number 2 are going to be backside tools. Number 3 is going to be a front side tool. So check the box, it puts the arrow back over there. Hit save, our Z is saved. It's got minus 12.536 in there for my Z. Now I'm going to go back to jog. I'm going to jog my axis in, and now I'm going to bring it in close. Now I want to turn my spindle on. You have a couple choices. You can either, what I'm going to do is turn the spindle on and move it in until I see it make a cut. And you can do the same thing on the face, that, or you can have a piece of shim stock that's 1/1000, 2/1000, and put that in there between the insert and the surface you're going to touch off on. Move it up and down and bring it in without a click until you feel it rub, and that's your contact there. So we're just going to do actual cut touch off for this. Right now I need to turn my spindle on, so I go to MDI, F2 MDI page. In the blank box right here, I'm going to punch in 1000, and then I'm going to hit spindle clockwise, and my spindle turns on. Okay. Now I'm going to go back to jog, okay, and I'm going to go to step mode. When I go to step mode, the continuous mode flashing red is going to turn off, so I know I'm in step mode. And I'm going to go Z, I'm at 10th out per click. Okay, another one is, I'm going to move it in until it looks like it's going to hit. Right there's pretty close. It's as close as I want to get at 10 thousandths per click. I'm going to go down to 1 thousandths, and I'm just going to click until it makes a cut. That's further away than I thought. Okay, right there I've got a cut. I'm going to go back to the MDI page, and I'm going to turn the spindle off. So this diameter is 0.375. I'm going to go to the F4 tool page. I'm going to double click on number 1 again. Right now on the x-axis, right here it asks what diameter it is. I'm just going to punch in 375, and then I'm going to click on touch. And I'm going to click on save, and it puts the value for, it takes that number right there plus half of the diameter and gives me my center position for my offset number. So right now for that tool, X and Z and X are both touched off. Then I'm going to go to continuous. I'm going to move away in the X. I'm going to move away in the Z. So I've got clearance right now. And I'm going to go to my next tool. Okay. When you're in your program and when you're moving from tool to tool, okay, especially in your program, you always want to be to a Z clearance point. And whenever you call up your next tool, you always want to move it in the X-axis first, and then come in on the Z-axis. And the reason for this is if you go Z-axis first, I'm in my program and I tell this one that I want to go to Z-axis first, then you end up with a situation where you end up crashing your tools because it's not clearance in the Z. So we go X-axis first. For this tool, it gets me in the ballpark. So right now I have to tell the computer that, or controller, that I'm using tool number 2. So I go to the MDI page, punch in T2, M6, screen changes to tool 2, so it knows I have tool 2 in the holder. And now I'm going to go back to jog, and I'm going to do the same thing, touch on the Z, touch on the X. So for this one I can make a cut, because it's actually the cutting edge that's going to touch. And I get it in the ballpark there, bring it into the Z, and I want to make sure I'm on that half of the part, that I'm not on my side of the center line. I'm going to go to the F2 MDI page and click the Spindle On, and I'm going to go back to jog, and I'm going to go to incremental, 10 thousandths per click, and I'm going to start jogging it in until I think I'm there, close. All right, that's real close. Okay, I'm going to go 1 thou per click now. I'm going to go until I hear it touch. Okay, and the other one is you will always hear it touch before you see. So listen, right there, I hear it touching. Okay, I'm going to go back to the MDI page and turn the spindle off. So for tool number 2, the front of the part is Z0. I'm going to go to the F4, double click on tool number, double click on tool number 2. For tool number 2, this is the turning tool. I'm just going to call it a 55 bore because it's a boring bar. 55 bore. I'm going to click 0 for Z axis, touches it off and puts my number in there. Again, you have front side or back side. This is cutting on the back side, so that's correct. And I'm going to hit save. All right, now I'm going to go back to jog, and I'm going to jog it away from the part on continuous. I'm going to jog clearance in the X, bring it down to a different place where the other one didn't touch off already, and now I'm going to come in the see how close I am. Pretty close. We'll go to 10 thousandths per click. We'll go to our MDI, turn the spindle on. Okay, now I'm going to go back to jog, and we're still in incremental. I'm going to go 10 again. I'm going to be pretty close now. I'm going to go to thousandths. 1, 2, 3, 4, 5, 6. Right there, I've got a touch, turn my spindle off, go back to the tooling page, double click on 2. Now I'm going to punch in the diameter of the stock that I just touched off on, 375, and I'm going to click on touch. Then I click save, so I've got my Z and my X numbers for my tool number 2. Go to jog, go to continuous, jog away in the X, jog away in the Z, make sure I'm cleared for all my tools in the Z axis. All right, now I'm going to go to MDI, and I'm going to tell it that I'm going to be working with tool number 3. So T3, M6, enter, changes my screen to tool number 3. I'll go jog, plus for my threading tool. I'm going to have a shoulder on this part, and I want to thread up as close as possible to the shoulder. So for this, whereas the 55 I touched on the side of the insert and then moved it half of the insert width, for the threading tool I'm going to touch on the lead side of the threading insert, and that's going to be my Z0. Because then if I program the turning tool to go 400 thousandths feet for the shoulder, and then I program the threading tool to go 400 thousandths feet for 390, I know that my threading tool is not going to crash the shoulder. If I'm trying to go by the lead, by the actual cutting point, you're almost always going to end up crashing the shoulder a little bit, okay? This way, I know it won't crash to begin with, and then I can actually creep it in as close as I can possibly get to the shoulder. So, we're going to go right inside, right there's good, I'm inside the diameter of the part. I'm going to turn on my spindle again, and we're just going to touch that insert to the face of the part. Okay, I'm going to go to jog again. We're still in continuous. That's pretty close. I'm going to go to step mode. We'll try 10. That's real close. We'll go to 1. And I'm going to move. Whoop, didn't change. I'll go to 1. Right there's my touch. I'm going to turn my spindle off. Okay, now we're going to go to F4. Double click on number 3. Okay, and for my name on this thread, and I'm going to click Z0, and it's my 0 point for my Z. Okay, this one is a front side tool, so there's no box checked. It's already on the front side. Okay, so that's correct. Save. Go back to jog. Jog it out in Z plus. Continuous. Z plus to get it away. X minus towards me. And Z minus to a fresh place on the part. There we go. Okay. Then I'm going to go X plus. Okay. All right. Another tip with your spindle off. If you have the insert over a dark surface, it's hard to see the gap between the tip of your insert and the actual side of the part. If you put your thumbnail underneath it or a piece of white paper, then you can see the spacing a lot easier. So I've got my thumb under there, and I'm going to keep in. I'm really close right there. Not too close, I'm not touching yet. So now I'm going to turn on my spindle again. I'm going to go back to jog, and I'll put it in step mode. And I think I'm close enough, so I should be thousands right now. And I'm going to click the X plus until I hear and see it touch. Right there. So I was within 4,000, that's not too bad. So now I'm going to go back to my F4, double click on tool number 3. And then I'm going to, for the X-axis, I'm going to punch in the diameter, 375, and hit touch. Save. I'm going to jog it out of the way, but all my tools are saved right now. Okay. Okay, if you have big fingers like I do and you have a problem typing and not having typos, the next thing I do is I actually move each of my tools to a position in front of the part to make sure that my offset numbers are all set correctly. Okay, so we're already on tool number 3. So what I generally do is we'll go to MDI, and this is just so you don't crash, and just a double check. So it's on tool number 3. G90 is absolute, GOO is rapid. Then I'll still tell it, right now I'm in front of everything, so if I move in the X, even if it goes past the part, I can't crash anything. So I'm in a safe zone. I'm going to say X 0.5. So that should be, 100 thousandths or so off the side of the part where it's at right now. Now I'm going to go Z 0.1, and if you have your finger on the escape button, if you hit escape, it's the same as speed hold. So if it looks like you're going to crash, you're going to hit enter. I just hit escape and it stops. So I'm going to go Z 0.5 again. Makes the rest of the move. Okay, so that looks like about ½ inch. Now I'm going to go Z 0.1. That's definitely 0.1. Z0. Okay, so I'm at 0.5 and 0. That looks good. Obviously my numbers are, there's nothing drastically wrong. So right now, I'm going to go to jog, and I'm going to move it out of the way. Okay. And then I do that with each of the tools, tool number 2, tool number 1, just to make sure that my numbers look good. All that is set. So the next part is going to be walking through the program. So, okay, so one more, since this is just dealing with offsets. You can, there's a couple different ways to do roughing and finishing tools. You've generated a program where this guy's roughing out the turning operation and this guy's coming in and finishing it. The other one would be a situation where this one is doing a finished turn on the front part of the part, and then it's coming in and doing a finished part on the back side of it. And because of the length that the material is sticking out, this diameter that's closest to the chuck is dead on the money, and this one is undersized because of vibration in the part. Okay, you can't easily go into the program and change the numbers for this diameter versus this diameter. So the easier way to do it would be to have two different offsets for the same tool. So if the first part of the program is doing a finished turn here, and then the next part of the program is doing a finished turn here, and this is tool number 2, I can tell in the program this is tool 2 for the first part and tool 12 for the second part. Okay, so then what we would do is we would go to MDI. We're going to tell it we're on tool number 2, so T2, M6. So it's got tool number 2 there, 55 bore. Now I'm going to tell it to go to G90, G00, X0. So my boring bar is going to 0. I'm going to go Z0. So my tool 2 is at X and Z0 right there. Okay. Now what I'm going to do in order to have a second offset number, so I'm going to go to the tool page and I'm going to double click on 12. So 2, 12, 3, 13, 4, 14 is basically what I use for double offset numbers. Tool number 12, and we're going to call it 55 bore 2 in my second offset. For the Z, I'm going to click, okay, I made a mistake. If you look at the screen right now in red, it's telling you that you're not on the tool that you're trying to adjust. Right now I'm going to get out of this, I'm just going to cancel, and I'm going to go to MDI, and I'm going to tell it that this is now tool number 12. So T12, M6. I'm going to get out of it, and I'm going to go to the tools, and I'm going to double click on tool 12. All right, and we're going to go 55 bore 2. Got the name in there. Right now where it is, I'm going to go 0 for Z, and I've got 0 diameter I'm going to touch, and then I'm going to go save. So right now if you look, your offset numbers for tool number 12 and tool number 2 are the same for the X and Z axis. So it's the same tool, but now you can use 2 different tool offset numbers in your program. So in the program, I would use tool offset number 2 to cut the front of the part, and then in the next program or further down in the program, I would call it tool number 12 to cut the back. Then if I have this one dead on and this one's off by a couple thou, I can just go in and shift my offset a couple thousandths on the tool offset page and run it, and the next part's dead on. And it's a much easier, more convenient way to play with your diameters and your dimensions on your program. So that's how you set up one tool with 2 different tool offset numbers. Okay, so right now I'm just going to jog it out of the way. And so I showed you how to send it home using G53. The other way is to go to MDI, call up the MDI page, and you have go home all access, and it sends both of them home. When you do that, it sends them both at the same time. I've got X and Z both moving. So in the next video, we're going to actually walk through running this whole part right here, but this is just covering tool offsets and tools. So that's it for this video. So check out the next one and we'll actually make the part. Thank you.